All right, everybody, so welcome. Good morning, good evening, good afternoon. Let's get started. Today's ratios and portions, and this is lesson 2.6, and of course I am Mr. Stiger. Today we're going to be in the book, so I want to make sure you guys have your books open as well as your notes. This lesson starts on page 115. Okay, please make sure you have it open to that page. Bell work. Ladies and gentlemen, upper left-hand corner, put lesson 2.6 and get started. All right, so with the bell work, ladies and gentlemen, let's solve these, okay? Pretty simple, straight up. The last time we did this lesson, most of you, I think, understood this concept. So I want to make sure going forward that you guys still do. Two things you do is 2k plus 1 equals 7, and then 2k plus 1 equals negative 7, right? And then you're solving. So next step would be to solve this up. Negative 1, just go across the board, split it, and solve it. Okay, so you have 2k plus 0, and then that would be 6. So you'd have 2k equals 6, basically. Divide both sides by 2. K equals 3. And then this one here, ladies and gentlemen, you'd have 2k. That would cancel out, negative 8. And then you would have k equals negative 4. Okay. Divide by 2. And that's what you get. So graph the solution set. I didn't provide a graph on this one. You guys know how to do it in a number line. If you're struggling with it, please let me know. As you read this, temperature of 2.4 degrees, okay? From the set temperature, the refrigerator is set at 40 degrees. What is the actual problem? Absolute value, right? And then you would solve for it. So when you would solve for it, you would just put t minus 2.4 equals 40, and then it would be t minus 2.4 equals negative 40, okay? Then you just solve. So when you actually solve this up, make sure you add 2.4 to both sides. All right, and then when you do that, ladies and gentlemen, what do you get your temperatures? The highest variance is going to be 42.4 degrees, and the lowest your temperature is going to get would be remember, it's going to be an absolute value, but when you stick this in there, it's going to be 38. I'm just thinking, it would be 37.6. Sorry, I was trying to do that math in my head. All right. Any questions on that? Please come see me. But in class, but I believe that is the right number. Plus 4 would be 8. Yep, that's right. Okay, sweet. All right, move on. This one here, you set up x plus 8 equals 13. X plus 8 equals negative 13. All right, you solve it up, same thing. Okay. Subtract 8 from both sides. You get x equals what? Negative 8, that would be 5. X equals negative 21. All right? Simple sets up. Hopefully you guys got it. Plug it back in if you want to test it out as well. Okay? All right. Now we're talking about mathematical practices 1, 3, 4, and 7 again. And we're going to be through some 3 more standards that we're going through, including real numbers. You evaluated percentages by using a proportion. Now you're going to compare ratios and solve proportions. So this is kind of a proportion lesson. It's going to should be fairly quick in nature. You do have a lot of vocabulary involved in this, just so you guys understand on your notes. Okay, on the very first section of your notes, you should have a lot of vocabulary in relation to ratio and proportion. Please make sure you circle the ratio part, all right, and then underline the definition for both. Make sure you guys continue to go through that so you guys can figure it out. All right, so we're talking about determining whether these two equations are equivalent ratios, right? yes or no, and justify your answers. So here's how you would do this, ladies and gentlemen. You have to ask yourself what numbers, okay, as you write it out. Let me make sure I did. What you want to do is make sure you write it out. How are you to go from 7, 8 over to, basically if you have equals, if you're divided by 1, okay, what would you get? Well, it's the same thing. But if you take 49 over 56 and you divide both the top and the bottom by 7, what do you get? You get 7 over 8. So 49 divided by 7 equals 7. 56 divided by 7 equals 8. So, is this equivalent ratios? The answer is yes, it is. Okay, they are equivalent. Guide to practice. You guys try right now. See if they are equivalent by doing the same model and definition. All right, so let's test this out real quick. See if we can do this. So if I have 6 over 10 and then equals 2 over 5, and then I have 1 over 6 equals 5 over 30, okay? What number would I basically multiply 6 by in order to get, or divide 6 by to get 2? Well, the only answer, honestly, to do that would be dividing it by 3. If I divide this by 3, so what that means is if I divide this by 3, can you actually divide 10 by 3? No, you cannot. So is this equivalent ratio? The answer is no, it is not. All right, same with this one here. Okay, the next one. If I go from here to here and here to here, what am I going from 1 to 5? I am going to multiply by 5. So if I multiply this by 5, 6 times 5, does it equal 30? Yes. So this is equivalent ratio, right? It's just a simple ratio thing to make sure that your pairs of ratios are equivalent. Proportion product. If A over B equals C over D, and B, D is not equal to 0, so these two cannot be 0, so you can have no zeros down here, then AB equals BC. So it's basically just saying cross multiplying, okay? But one thing I want to make sure, I want to change with what this book states. So lesson example 2, ladies and gentlemen, does start on page 116, okay? And they kind of give you a great illustration of how you can cross multiply. So what I mean by that is you guys learned this, I believe, in middle school last year. I had some students approach me when we were doing a different style exercise, and they were basically telling me, oh, my teacher taught me this way, this is what you're supposed to do, and I said, great, show me how you're doing it. And so they would show me how you're doing it, and the problem is sometimes you take it too far in steps, and I'll show you what I mean. So what you want to do is you can cross multiply these ratios. So this number goes over here, and then this number goes over there. All right, so when you cross multiply, you're basically saying 2 times 0.25 equals, and then this would be 0.6 times 1.25, okay? Now, what you do in this case is, let me grab my calculator, and you're seeing if these two numbers are the same, if the ratio is the same, okay? So, I have 2 times 0.25, and that equals 0.5. And then I have 0.6 times 1.25, and that equals 0.75. So ladies and gentlemen, is the ratio the same on here? Okay? Is it? The answer is no, it is not. Okay? Since 6 and 0.75 do not match, it is not a valid ratio. Original proportion. Here we go. Cross products do not equal, so the ratios do not form a proportion. Now, ladies and gentlemen, let's try this one. Okay? See if you can do here. So, what you're doing is you set it up. 2 over 2.5 equals 16 over 20. All right, then you're going to cross multiply it. This is going to go over to here. That's going to go over to there. Okay? And then what you do, ladies and gentlemen, is when you multiply it out, you have 20 times 2 equals 16 times 2.5. Let's enter in the calculator. I ain't got to do this one. I know this is 40 equals that. But 16 times 2.5 that equals 40 as well. So are they proportionate? Is it the same ratio? The answer is yes. Okay? Whoops. Pen's starting to go a little squirrely on me. The answer is yes, it is. Okay? It is proportionate. Hopefully you guys understand the cross products are equal, so the ratio forms a proportion. Here's the cross multiplying part. Okay? 2 times 20, see how they bring it down? They bring that to there. 2 times 20 equals 2.5 equals 16, 40, 40. Good to go. Your turn, ladies and gentlemen. You try, please. All right, on this, just cross multiply the platform. So it's going to be 0.2 times 0.9. That's going to equal 1.8 times 1. I already know that this is going to be 0.8. If I multiply 0.2 times 0.9, that's going to equal 0.18. So unfortunately, ladies and gentlemen, this is a no. Okay? You do this one here. This is going to be 36 times 35 equals 15 times 42. I don't know about you, but I cannot do that math in my head. All right, that's 1260. And then 42 times 15 equals 630. Okay, so neither one, it looks like, are proportionate. That's a no as well. So this is kind of just one of those things to make sure you guys understand. Don't get confused. All right, solve the proportion. This is where things are going to get a little different than what's in the book, ladies and gentlemen, because I don't want you to take the extra step involved in this, okay? The book is telling you, ladies and gentlemen, you take this, okay, or let me rephrase that, okay? You would basically take this proportion over here and multiply it by that, and then you take this proportion, multiply it by that. But ladies and gentlemen, when you do that, you would get 12 times 3 is 636 equals 8n. Then what you would do is divide both sides by 8. Instead of doing that, ladies and gentlemen, so let me show you what it's doing, okay? Divide by 8, all right? So you end up with these cross out, all right? And then what happens is we have 36 over 8, so you have n equals 4, okay? What I want you guys to do is understand when you're cross multiplying and solve as the proportion is that I want you to do just one of the steps, okay? What I mean by that is it's nice that they have this proportion, but I want you to get rid of the fraction first, and then that's it. Let's just leave it at that, ladies and gentlemen, okay? So what I mean by that is because I understand about the principle and philosophy of this, and I know you guys do as well, but sometimes it's not, I don't want to justify the extra steps because I want you to get to the answer quicker than what you can, and so let's do that. Times by 12. All right, if you do that, remember that's 12 over 1, both sides by 12 over 1. Then you get n equals 36 over 8. See, you get that right away instead of getting 8n equals 36, then dividing and solving. So you just simplify, n equals 4. Okay? All right, this one here on B, what I want you guys to do is do the cross proportion. Okay? But what I want you to do is only do one. So what I mean by that is this 12 goes over here. So it's going to be x plus 4 equals 36 over 4. Okay? Can you simplify that? Now, I did 12 times 3, just to let you guys know. Can you simplify that? Yes, you can. 36 divided by 4, ladies and gentlemen, I believe is 9. Okay? X plus 4 equals 9. Subtract 4 from both sides. X equals 5. You can plug it back in and see what you get. If you plug it in, you get 9 over 12. Ladies and gentlemen, 9 over 12 does equal 3 over 4. All right, your turn. Okay, with this equation, ladies and gentlemen, do what I asked. Take this, bring it over to there. R equals 25 times 8 over 40. 25 times 8 is 200, okay? I was trying to do that math in my head as I wrote it, which equals 5. Okay, cross the zeros out. 20 divided by 4 is 5. This one over here, do the same cross multiplication over. So it'll be x plus 4 equals 15 over 8. Okay, 15 over 8. Can that be reduced down? Yes, it can. All right. When you reduce it down, it can be reduced down. But first, you can reduce it down to 5 over. Is that 3? No, wait, not 5 over 3. I'm trying to think. Can you reduce it down? No. Okay. So what you would want to do is the next step would be subtract 4 from both sides. Okay. And then I'm going to use my calculator. I have 15 divided by 8. All right, and then we're going to divide that, or we're going to subtract 4. You subtract 4 from it, ladies and gentlemen, you get x equals negative 17 over 8. Okay? If you guys struggle with that, let me know. Okay? But that's kind of the main principle with it. It's nice that you get a nice, if you want to convert it to a decimal, you can. Okay? Negative 17 divided by 8. Whoops. 8 equals 2.13. All right, but you could leave it at that fraction as well. Just enter it in the calculator. All right, the gear on a bicycle is the ratio is 8 to 5. Okay, this means that for every 8 turns of the pedal, the wheel turns 5 times. Suppose the bicycle wheel turns 2,435 times during a trip. How many times would you have to crank the pedals during the trip? So what we're trying to do, ladies and gentlemen, is set up this problem. Okay, so let's set it up. P is going to represent the number of pedal turns. So what you do is write a proportion for the problem. So write this proportion down. Pedal turns on the top, wheel turns on the bottom. Pedal turns on the top, wheel turns on the bottom. It's a prepared proportion. Okay. Then all you do is you would just solve. Okay, so if we have this proportion set up here, come on, stay with me now. You have this proportion here, ladies and gentlemen. Well, how would you solve it next? Well, technically speaking, you could do the cross multiplying, or you take this number and you multiply it up there. So it would be P equals 2,435 times 8 divided by 5. Ladies and gentlemen, I do not know what that is off the top of my head. So let's do 2,435 times 8, right? This equals 19,480. It's going to be divided by 5. Divide that by 5, and you get 3,896. So, what was how many pedal turns did they have with this proportion? 3,896 pedal turns. All right, guys. What I want you guys to do is please look at this. Look in your book too and see if you can find kind of the answer or the example of how to do it. The example would be on 117, but the actual answer, ladies and gentlemen, does go to 118. Okay, you try now. All right, it takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can she walk around the track in a half hour? Okay, so the proportion is 7 over 30. Okay, when she walks around the gym, all right, she walks around the gym twice. She's already hit the track twice, so on this side, if she goes 7 minutes, it's 2. So what are we looking for? The proportion here. All right, solve the equation, ladies and gentlemen. This is how you would set this up. Make sure you guys have the correct thing. So, first thing we have is, when I'm looking at this, how many times can she walk around the track in a half hour? It's over 30. Now, what you want to do is, you can, there is a property that you could use where we could flip this proportion, okay? So, since this is just proportion we're writing, let's flip this bad boy to make it easier to solve, okay? I wrote it like this. Does that mean I need to solve it like that? Not necessarily, okay? So now what you would do, ladies and gentlemen, is let's do the proportion over. That goes over there. So you would have 30 times 2 is what? 60. 60 over 7 is x. So if you want to simplify it out, let's make sure we have it, because it's asking you about how many times you walk around the track. You do want to not leave this one at a decimal, so it'd be 60 divided by 7, and that does equals, she walks around the track 8.6 times. Okay, hopefully you guys understood that. See, what we could have done is we could have done the cross multiplication where we get 7x equals 60, right? Because the x would come up here, and that will go there, and then you would divide by 7. Basically gets what? Gets the same thing, okay? I just did the flip. You could have done it this way as well. It's fine. Just know that, you see, as we wrote it, okay, we actually got the right answer coming up. The very last thing is talks about a map, scale models, okay? In a road atlas, the scale for the map of Connecticut, let me make sure, is 5 inches equals 41 miles. Okay, so 5 inches equals 41 miles. So you can go inch and miles. All right. What is the distance in miles represented by 2.5 inches on the map? Okay, so 2.5 can be written as 2.5 inches equals x miles. Okay, ladies and gentlemen, let's do the cross multiplication on this so we can get this one kind of close. All right. So what I mean by that is, as we wrote it down, okay, we can now write it. We can now simplify it. Take this up to there. Let's go the 41 up to there. Okay, so we have 5x equals, and then what is 41 times 2.5? Okay, that equals 102.5. And we're going to divide that by 5. Divide that by 5. Your answer comes out to be x equals 20.5. Now, what does x equal? Okay, what is the distance in miles represented by 2.5 inches? It'd be 20.5 miles. All right, make sure you guys finish the annotation on that as we go through. All right, hopefully you guys understand this process. So what it is a good ratio of trying to figure things out. Okay, now it's your turn, ladies and gentlemen. And look, let's see if I got it right. Ooh, I did. Okay, I set it up correctly. All right, that's what I wanted to see and make sure. 5 over 41, 2.5 over d. Solve it, ready to go. It's your turn, ladies and gentlemen. Use the same ratio. Write it down as you see it, and you guys can figure it out. All right, last example, ladies and gentlemen. 5 centimeters over 2 meters equals 28.5 centimeters over x. All right, I'm not going to put x down because that'd be creepy for you guys. So let's cross multiply it out, okay? If you do the cross multiplication on this one, this x goes up there, the 2 goes up there, okay? So you have 5x equals 28.5 times 2 is 57. And then 57 divided by 5. All right, because what you're going to do is make sure you guys know, divided by 5, x equals 11.4. And what are we looking for? The bottom, meters. Ladies and gentlemen, this proportion and scale is kind of good for you guys to know how to, it's a good practice in cross multiplying. A lot of times when you guys see these fractions, especially with the earlier examples, you get kind of freaked out. So I want to make sure that you guys know how to do the ratio and proportion as we move forward. As always, if you have any questions, please come see me. I hope you learned a lot about proportion and ratio in this lesson. In the meantime, ladies and gentlemen, have a great day.